So we will be waiting for 3 more minutes and we'll start. Okay, let's start. So please let me know if you can hear me very well and if you can see me well, if you can see the screen. We're gonna start our lectures and we're gonna start this course. So the name of the course is Social Media Computing. It's about processing social media data, which is a very exciting topic because social media data is not just data. It's not just like structured database that you could process. It's not just some conventional type of data we usually have, but it's rather very unstructured data that generated by humans. And therefore, whatever techniques you will learn in this course, whatever you understand in this course, this will be applicable to pretty much most of modern machine learning tasks, machine learning jobs, when it comes to processing a large amounts of data based on large user interactions and reach. So today's introductory lecture is meant to let you understand whether you like it, whether you think it's something you really want to learn in this semester, and also to give you a brief overview what is so special about social media data processing, machine learning, so that you can really understand how exciting it is and why researchers like me are so happy to work on this for many years already, and we gonna work for many years longer than that. In this course, I'll be assisted by two lab members of the machine learning lab. One of them is Chi Yang. He is not here today. He is on medical leave, but he'll be joining you in the next lecture. And also Iman Hosseini, who is here, and you'll be happy to answer your questions if you have any after the course. My name is Aleks Farseev. I'm a professor in ITMO University in machine learning lab. And I also am a head of the media lab under machine learning lab. So we are doing everything related to multimedia data processing. And this is what this whole course is about. So we are going to you're going to talk about what the actual research me and my colleagues are doing on a daily basis. Let's start. So we're going to talk about our current age of social media, about different social media platforms, about observatories that meant to observe and make conclusions based on this social media data, some challenges that we face when we process social media data, and some specific course arrangement related to this particular course. We are living in a new information age. And this all happened when internet came into picture. So basically before we had phones, we had a lot of physical interactions, but then internet has came in and it has turned the whole world upside down. And then when such things as COVID has happened, it has impacted us even more. And this is, for example, the reason why we have this lecture online rather than I meet you guys in a university, as you would usually expect it happen in master programs. So this has impacted our life a lot. And if we look into the types of data that circulate between people, it also has been changed from purely text, but becoming so-called multimodal live media data. The way we interact with all the social media apps, with modern ways of interaction through TikToks and other platforms you all guys use, this has transformed the way we communicate. So we get a lot of so-called end-user generated data. It's called UGC, user-generated data. We will use this term a lot in the future. So the point here is that data is get generated by users actually. It's not get generated by, let's say, professional editors. It's just generated by everybody in the internet. We get a lot of data streams coming from Internet of Things. Just right now in a neighbor room, my Xiaomi vacuum cleaner sends the messages to my mobile phone about how well it's doing a cleaning in my flat. And this is very much about Internet of Things because this data also flies back to Xiaomi servers. They do a lot of research on that. So this is quite rich data. And of course, the third one is about the mobile data that get accessible all over the world. So it's happened in very developed countries. It happened in the countries that are developing at the moment. Many people use mobile phones, all the way from megapolis all the way to monasteries, right? And this they all generated data, and this data can be processed. This data impact how does everybody live on the earth nowadays. So if you look in the size of internet, even in 2016, it was estimated as 7.7 zettabyte. And if you see the table on the right bottom corner, the zettabyte is bigger than exabyte, which is bigger than petabyte, and which is bigger than terabyte. Probably terabyte is something you have heard about, but the rest, 3-digit additions, you haven't heard. So it's really huge. If you look in 2020 numbers data, it will be actually way bigger than in 2016. I deliberately didn't put it just to get a little bit of research spirit in you, so you can go search how big the internet is nowadays in 2020. So if you look in the size of particular platforms in internet, and in particular how much they process in internet, you can see that Google, for example, performing more than 12 billion search queries every month that gets searched by every user in Google. And it indexes 35 trillion web pages. But this index is only about 4% of what exists on the internet. And while the rest of the information is actually not indexed. And the answer is why the information is not indexed. The answer is because these web pages are pretty much generated. They can be generated by scripts, like, I don't know, some dynamic scripting languages. They can be even generated by humans in social networks. So it doesn't really make sense to index them because, like, say, Instagram stories, they'll appear and they'll disappear again. But they actually comprise the biggest part of internet size nowadays. And we need to take account of this. We need to understand that a very huge number of data in internet is not indexed. And one of the biggest challenge nowadays for computational science is actually how to process all this data, make sense of it, and get knowledge on it. Because just data itself is not useful. You need to be able to structure it, figure out the relationships, and really make it consumable by human, make sense of it, or gain insights, actionable insights from this data. So, of course, Google also indexes some private data that you use. And this data can be, let's say, our photos that we upload, our paths daily, Google Map, in Apple Health, wherever, our sport tracking bands that we wear, they all continuously feed these companies with the data. This data gets indexed, and then they build a very broad picture of us, which is called user profiling, by the way. And one of your lab in this model will be about user profiling, about predicting people personality based on the data that Google's and Facebook of our world actually collect about us. It's very exciting. Then if you look into way people communicated before and now, you will see that last time when we had a fax, maybe phone, maybe traditional mail, the communication was mainly one-to-one. And nowadays the communication went through broadcast communication to one-to-many, or even many-to-many communication. So if you look in a broadcast media, it was, let's say, one journalist or one radio speaker talking about everybody right around. And it was very highly moderated information. This moderated information, of course, can be later used, can be consumed by people in the newspapers, etc., etc. When it comes to many communication, this is pretty much uncontrollable. And as we just learned, this information is also not indexed in the internet. So it's like a huge, big data. You can call it big mess that needs to you need to get sense of in order to understand it, in order to make use of it. So if you look into the sequence of actions that's happening, you'll see that in broadcast media, it's usually data get filtered first and then it gets published. But in social media, data actually get published first and then it gets filtered by those entities that are trying to process this data. There's also there's a big difference, and this is often reflected. Let's say, like Donald Trump might post something on internet, and then everybody after that starts filtering this information, and this differentiates a lot the social media data from the traditional way to the new way. So then maybe if you go to look further, you can see that in 1 minute, internet actually collects a lot of information from all these social media data sources with this many-to-many communication. And of course, companies like Google, Facebook, Netflix, other social network, and let's say content aggregation platforms, they need to have very huge capacities to process this data. What does it mean for us? to us, this also means that processing data and figuring out the relationship in the data is not the only problem that the industry faces. I would say the bigger problems the industry faces is how to apply these algorithms that we come up with into the really huge data. Imagine every 60 seconds you're going to get billions of data points. How to apply these algorithms into such a huge data, how to build systems that can be really distributed and highly scalable in order to process all this data in a necessary tempo. So if you go into the general characteristics of social media, you could say that social media, everybody can be a source of the media outlets. So we can really impact. We can be social influencers on Instagram with million followers, and whatever we say will impact a lot of people, like bloggers do. Last time it was not possible, now it is. The interactions between people are much richer than before. It's about various types of content. The content gets user generated as well, so we don't filter content prior. It goes online and everybody can see it. People enriching content by liking, commenting it, and that creates a new piece of information that's already about the relationship between people. This relationship forms this collaborative environment that overall forms the collective wisdom. And all this is very long tail. So long tail I haven't touched yet in this course, but idea here is that in mathematics we have distributions. So distributions that have a very big head, like big spike of something that of some rare items, and then very, very, very long tail of something that happen not that often. It's called long tail distribution. So social media is very long tailed. We have a lot of rare actions that we get repeated just several times, and not that many actions that get repeated too often. Let's say people don't write exactly the same phrases in social media; they write differently, right? So that's why it's long tail. Working with long tail distribution is quite a challenge by itself, because when you want to technically process such data as texts, as images, you have to put much more efforts on how to make your data representation to handle this kind of activities. Otherwise, let's say your features, if you are familiar with machine learning, you know these features, right? So your features might not even be compatible with your user data because you just didn't use the words that your features contain. Something like this, right? We will put much more time on this in the next lecture, and in the following lecture we're talking about natural language processing. But overall, this is a challenge, and it's not just about natural language; it's also about the visual content, the videos, the images, etc., etc. You need to know how to take care of it. So, what are these social media platforms? Well, I'll just give these three for you as examples because they are different in terms of their purpose. So I will talk about Facebook, let's say LinkedIn and Twitter. And you know, what is interesting here is that if, let's say, in Singapore, Facebook is considered to be a private platform, private communication, right? Similar to WhatsApp, let's say, right? LinkedIn is considered to be, let's say, professional communication medium, and then Twitter is quite a public platform. You could actually notice that, let's say, in Russia, where you are located at the moment, we might have all these things shifted very much. And in China, we might have it shifted again. We don't have these social networks at all. So, for example, in Russia, LinkedIn almost doesn't exist. Nobody really have accounts inside there. Facebook is considered to be a kind of a professional network where people connect to each other and they're trying to build their professional profile, try to put their career path there, etc., etc. And Twitter is also a little bit business/professional/public type of media. And networks like VK or like Classmates and Naklassniki is considered to be more private ones. So they play a role of Facebook, but in Russia. So there's difference from region to region. We also have so-called media sharing platforms, and I think the one we don't have here in the list, and it definitely should be in, is a TikTok. But except for that, we also have Instagram, YouTube, Periscope, Flickr, like really really big, large platforms that help you to share content. And of course, we also have the messaging platforms, which can be, okay, in Russia it will be Viber. Overall, it can be also app called Line, of course WhatsApp, of course Telegram, the channel where we all communicate for this course, WeChat in China and for the Chinese community globally, and a couple of other platforms. So we also have so-called location-based services, and if last time location-based services were pretty much dedicated, so let's say Foursquare was very dedicated just into doing check-ins in particular place and basically showing where are you now at the moment. Nowadays, pretty much all platforms have these location services enabled, so that our Facebook has its own location service. Our Instagram has also its own location service tagging, and we have it in LinkedIn, we have it everywhere, and this platform actually encourages us or even automatically put locations inside our posts. So you can say that pretty much any social networks nowadays is a location-based social network. We also have so-called social curation platforms like a Pinterest, where you can pin certain things, and these platforms are very good for research because we have a lot of so-called ground truth data from where we can figure out what is actual intentions of people, what they really actually like. And of course, for users, it's also a lot of fun because they can build the boards, they can categorize things, and then they can share these boards to their friends, so they can have fun discussing what is out there. They like maybe particular products, particular clothes, etc., etc. Pinterest's population predominantly is female population because of this categorization and discussion features there. And obviously, you can notice, and especially with TikTok, right? Most of recent apps, they're all video based. They all very much into video interactive format, and we believe that video and furthermore it will be also augmented reality, virtual reality is the future. So if you are considering start doing research or looking for a job in the industry, I would think that skills related to processing visual information, video information, virtual reality, augmented reality will be very, very, very popular. It will be very, very, very necessary for the industry, and it will be high demand. So consider to tap into that industry for your career as well. Overall, user is the center of social media. Everything is got around the user, and when it comes to the actual service, let's say of the Facebook or Google, it's all about the users. If you talk about how they monetize their services, like advertisement, that is also about the businesses, right? But even those businesses, in order to make use of this advertisement on social media, they have to spend their marketing dollars to show the ad to the users. So users are anyhow, in any way, either consumers of the ads or consumers of the content itself. So this is how it works. And that's why most of analytics you'll be doing, most of your lab works that you'll be doing, it will be related to users, processing the user information. And this is all about it. Okay, so what are the key functions of social media? Of course, communication that was built for in the beginning to share something, to interact with people, to, let's say, Twitter get used for updating people, interacting with press, but also we want to do our expression. We also want to motivate and self-preserve there. So we want to talk about, let's say, wellness, exercise, self-improvements. And that could be like there's a social network called Endomondo, for example, right? It was bought over by Under Armour a few years ago. So that's about running, about achievements, and this is also this type of social networks. And also it's to represent local communities. So even Facebook itself originally was internal university network. It actually was a local community network, but then it grew up. Same as VK in Russia, it was university network first. it gets a core user base in a university when it was local community, then it grow up on the whole Russia and around Russia and ex-Soviet countries. So they also migrate from one category to another. And in terms of provider perspective, like those platform that provide, of course, social networks are aiming at attracting and retaining users. They employ a lot of innovation, fun, and new services to attract new users and retain them. And like TikTok get a very new format for videos, and Instagram get this filters feature, right, to attract their users. And then, of course, they want to understand the users and how they co-create and co-view the content. And that binds back to the monetization schemas that works, right? If you manage to maintain a good content in social networks, in your social networks that you own as a resource, and you eventually able to monetize these good quality users into your revenues from advertisement. That will be, so the platform will be used actually by brands to advertise to you. And they need to be sure that you are interested in social network. If you walk away, then there will be no audience for the advertisement. Then social network will not gain the revenues that they want. So they have to be a very good balance between their own monetization strategy and also between the services they offer. So, but of course, they all have to survive. They don't want to be like Twitter, always like a non-profitable company. So they also have to find a balanced way to earn money from advertisement usually. So Facebook itself, yeah, that's a wrong writing. You have to be a smaller b there, but Facebook itself, in terms of traffic, is really huge. It have way more than 2 billion active users in 2020. And of course, if you look overall, you will see that Facebook has dominated, and together with Instagram, together with all these platforms in the Facebook infrastructure, they have dominated a lot in the countries with a very developed mobile internet, like Indonesia, like India, like Philippines. And let's say if you look into Instagram, you will see that Instagram, I guess, is number 7 in the world in Russia as well. So actually, it's quite powerful in the countries that develop a lot of mobile internet, that are very advanced in terms of B2C sector, where people use these devices a lot. And of course, for Instagram is the same. As I mentioned before, that they come up with this new feature of this kind of filters, right? And then they get acquired by Facebook in 2013. Then we see explosive growth for the social network together in Facebook infrastructure. So that overall, Instagram has gained a lot of popularity and become one of the dominant social networks, not just for users, but also for advertisers to place their ads. Let's say in Russia, for example, what is really used the most is the Instagram advertisement placement for advertising goods to people, because Russians really on Instagram. And guess what will be next? Next will be TikTok like this. If you later will see the plot, you will see that TikTok is almost pick up the Instagram performance, and then it will be a next big thing in internet. We also have Twitter, that is mostly about microblogs, and it used to be and remains to be one of the largest social networks. Especially it's popular in the markets like Japan, markets like US, and it holds its positions. So of course, Twitter is mostly public messages. They're restricted in terms of number of characters you put, and it serves this particular purpose. Usually Twitter is also treated more professional, more kind of business blogging type of media for people to release. So yeah, as I say, there's a certain characteristics of Twitter that are very distinct, like you can only post 140 characters. And that, of course, puts a lot of challenges into analytics as well, right? Because let's say most of these machine learning models that were created were meant to analyze really structured, nicely written texts, like natural language processing, traditional one. It was like a structured, nicely written text created by maybe professional editor, proofread, and all this. Now we have Twitter. It's 140 characters with the typos. You really don't know what the person really meant. Sometimes one message spread out of several tweets. It evolves all the time. You're also not sure whether it's a person wrote or maybe a secretary wrote for him. If it's like somebody, some like a busy public person. This all poses challenges for NLP tools to process that. And Twitter have pioneered a couple of now very common features like follow, like retweet, and reply to particular things. So each of the social networks bring new features and later get adopted by the rest. It's very conversational in nature. And if you look at this example, you can see that Twitter also can be a very, very good indicator of what people are interested in, what people are about. It's constantly evolving. So you can, by monitoring somebody's Twitter timeline, you can actually see how does the mood of the person evolves, how does the life of this particular guy evolve. So now if you can monitor it all holistically, you can see the overall picture of Twitter feeds for, like I say, region. You can actually track different life events, community events, trades, maybe trends, hypes, much faster. You can track it in Twitter as compared to you would be using some traditional media or you go looking for newspapers. So Twitter is very good as a social sensor. You can sense from a Twitter that something's going to happen, and after that you can try to figure out what is going to happen from other data sources. And also that's why Twitter is so popular when it comes to stock prediction, stock market prediction. So Twitter is a very popular resource because it's very reactive on this kind of fluctuations in the world. If you talk about business model, as I mentioned before, Twitter was not as aggressive as other social networks in terms of building their sustainable revenue model. So till very recent, they actually still didn't find the best way how to monetize. And once they plug in the advertisement channel to advertise on Twitter, they were quite late. They were already when this has happened already when Facebook and Google have pretty much occupied and dominated this digital marketing infrastructure. So Twitter was not that common, and there was not that huge budgets were spent on Twitter because brands didn't really believe that Twitter can really reach customers at necessary level to do a business impact for them. So Twitter also strong in data analytics. So I would say that data itself, again, I mentioned it earlier, is not as high impact as compared to meaningful processing of the data, structure of the data. So actually, Twitter community and the Twitter data analytics team are quite famous for bringing a lot of new data insights. So if you look into research community, you can see that there's a lot of research papers and new algorithms are developed based on Twitter data, and there's two reasons. First is Twitter data is very live and special, right? So it's just research-wise, it's interesting how to process such a short text. But also Twitter data is the most available. If you look into APIs, you'll see that Facebook really closed all public data. They don't really give you access to the people's public data, only to the brand's data. Same for Instagram. You probably have heard about this Cambridge Analytica story before, right? Same for other social networks, but Twitter is very open. They actually still can get you get the recent data, and recently there was even Stream API available. You can just get the live stream data for Twitter. And that's why in this module, we will be using and relying on Twitter data a lot, just because we can legally get quite a bit of Twitter data. And then you can play with this data, and then each of you will be working with real life data coming from internet, but not just some outdated data sets or some Kaggle data sets you can get. So that if you want to, right, you can choose it for your final project, or you can even utilize in your lab work. So we have visual-based platforms like Snapchat, like TikTok, and I think key features here is that content disappears, like Instagram stories, like TikTok, like Snapchat. It actually get posted and then it disappears. It doesn't store inside the social network inside. So it becomes like an interaction between people through the visual content. And this gets also very, very popular worldwide. And I think your generation knows this better than me. Why would you like to use this kind of platforms? So if you look in the demographics, you can see that monthly active users in Snapchat was about 255 million, and 53%, so more than half of them, were less than 34 years old. And then 28% of users in the US are younger than 24 years old. And this also holds for the TikTok, very, very similar statistics. So that was more about the temporal real-time videos that you can post on TikTok, and then on Snapchat, and then pretty similar interaction model happening on TikTok as well. You can just browse the lines, you can just watch somebody's short videos, appreciate, react and respond on them, and so on. So this is very common for all the video annotation networks. Another one is called Vine, right? So it's quite a bit of them. So then there is a Pinterest. It's in Pinterest we have so-called visual discovery features, and then we can actually pin the content to particular boards that we create between each other, and we can share this board. So Pinterest is very common among female users particularly, and the topics that people discuss and pin there is about fashion, about pets, I don't know, some home decor, etc., etc. So so why people would use it, right? So people like to interact, discover, and they try to find like-minded individuals. And this is again tied back to the original purpose of social networks. And if you look in who is using this, you will see that almost 70% are females. So if you go in further, you will see that brands, again, and this is again, in order to monetize social network, you have to plug in the brand inside. So brands are very active in Pinterest as well. They can collect a selection of similar pins, and they can do advertisement inside there, and then they can allocate themselves in a particular necessary place, so that they can really enjoy the communication inside the platform. And of course, there's also standard features like likes, like followers and following. So this one you will see in other social networks. Then there was and there is Foursquare. We're talking about Foursquare in particular because Foursquare is one of the first movers in this space. So they created so-called location-based social network, where people were actually making check-ins in particular locations, and then they were sharing these check-ins with their friends in their network. My group did quite a bit of research in these social networks, location-based social networks, and I think what is the key interesting part here is that you can actually really know where a person travels, and not just where a person travels, but also what type of place the person has visited. And I think this is very important because you know the semantics of the place, the venue semantics. So based on the semantics of the particular types of places where the guy went to, you can infer a lot. You can infer, let's say with 80% accuracy, you can infer whether this guy is single or married just based on location data aligned in the particular timings. So you know the time, and you also know the type of place. So it's very accurate in predicting whether the guy is married or a bachelor. You can Google Donald Trump bachelor AI, you'll find more than 100 articles about our research group, and we published one of the papers, and that was about location data mining as well. So there's a bunch of other networks, and as I say, Facebook, Instagram, and Twitter, they are also per se location-based social networks nowadays because they have a lot of location. But Foursquare was on the first, and Foursquare only did that, while others do everything else. So that's why it's so special. You could draw quite beautiful maps, heat maps of locations, and you can see where people travel with this kind of lines. You can see the so-called mobility patterns, and mobility patterns is another very interesting direction. If you look for mobility mining in social media, let's say in Google Scholar or in Google, you can find quite a bit of research about how people analyze the population mobility in a really, very large scale based on the data from location-based social networks like Foursquare. So this is just to show you that there is also semantics of the menu, so you can see how many people visited this, what is the average check, what are the particular, how does the venue look. So you're not just getting the location data, not just getting a particular guy visited this location, but you're also getting information about visual content there. How does it look? What type of venue is this? Is it, let's say, a garden, a restaurant, or maybe a club, pub, etc. And then this is very useful. Later you will see how useful is this actually for doing a large-scale prediction of different things based on social media data. One of your labs will be about that. And if you go further, you can also notice that we have platforms like Meetup. They're trying to bridge online with offline. So basically our offline meetings get bring into online and then back. These platforms get especially very relevant during the COVID virus because we were not really allowed to meet physically much. So we need this kind of online to offline interaction venues, and then companies who address this problem on the business side, they really gain very good valuation and they grow very fast because this is really important problem nowadays. So Meetup particularly is the world's largest network of local groups. People organize these local groups, and then you can find a group to meet face-to-face or virtually in Zoom. You can connect to people with similar interests, activities, and then you can actually capture face-to-face interaction. For research, for us, it's also important that we actually can utilize this online to offline data to do very interesting research. How does our social media life affect our physical life, and then vice versa, how our physical life affects the way we interact with social media. So this is very interesting. User base is about, now it's more than 8 million. It used to be 8 million in 2 years back, I think. And it's quite wide. It's more than 100 countries and more than 80,000 meetup groups available. So this is 2020 data, just to give you the most recent picture. This is from Statista. So you can see that Facebook still dominates among all other social networks. And it's not just dominates as Facebook itself social network, right? Because I would say that Facebook is not as active as before. It just has many users, but it also effectively captures the whole ecosystem of the communication channels nowadays on social media. So you can see the number 3 is WhatsApp. It's owned by Facebook. Number 4 is Facebook's own messenger, and it's owned by Facebook. Number 6 is Instagram, which is also owned by Facebook. And then we have WeChat. WeChat is a Chinese counterpart, as I say, affects the Chinese community. We have YouTube owned by Google, and obviously we have TikTok, right? Who might even jump higher than Instagram very soon and become next Instagram. That's how people call it. So, and you have probably heard that TikTok might get acquired by non-Chinese companies. So we'll know this soon. Yeah. So that's it about social networks. But how about analysis of? I mean, I told a lot here about how complex this data is, how difficult to process it, but well, how are we going to do it? And what are the key metrics of social networks? So I would say that the key metric, of course, is a number of monthly, daily active users. And this metric is not just the key metric for social networks, but it's also general key metric for B2C businesses. And social networks are obviously B2C businesses, right? In terms of, not in terms of monetization, but in terms of the concept itself. The key driver of the business is B2C. So to compare them, you need to see how well they do in terms of number of active users. You want to look also at demographics of these people, because demographics is directly related to monetization strategy. Many brands don't advertise on TikTok because TikTok users are too young, and it just doesn't make sense. These people will click, like, whatever, they will never convert, and that's why demographics is very important. You also want to see whether social network is more public oriented, like Twitter, or more the user or friend oriented, like Facebook. And of course, most of the monetization schemas are based on advertisements. So public networks have a less compelling business models here as well, right? Because when it's come to public, then they have to give up a lot of content organically. So then it's a less initiative for brands actually to tap into the paid media infrastructure of the network rather than just spin off the organic posting. But to be honest, recently also social networks trying to reduce the number of people that really see our content and increase the necessity for brands to actually advertise and put the money into the ecosystem, because all the social networks need to survive. So many social networks are trying to move to e-commerce. For example, Facebook is extremely focused nowadays on how to make brands run ads on Facebook based on information that they get in the retail stores. Let's say you have your, I don't know, Peterочка, right? It's a hypermarket chain in Russia. If you want to, how to run advertisement on Peterочка based on the grandma's loyalty card, right? So how to make sure that grandma who tap card in the Peterочка later will see advertisement on her son's smart TV with the right sausage, so that she'll go and tap it again and again and again, right? So this e-commerce, this online to offline commerce are very, very hot topic nowadays. And then they all try to tap into this monetization. Really a lot of money gets spent. Newer social media networks are video-based, and you have quite a bit of challenges related to noise, spam, and the privacy concerns. Privacy is especially, I mean, most of news you'll read about Facebook recently will be about privacy concerns. A few months ago, many brands in the world even decided not to advertise on Facebook because of this hatery speech. Before that, Facebook had problem with the user privacy, right? Because Cambridge Analytica have used some data it's not supposed to use for some analytics to influence the certain process in the US government. So what are the systems that get built on the industrial level and also on the research level? So we have something called social media observatories. Social media observatories is pretty much mediums that are trying to capture these relationships across the user and try to collect a load of information about the user and make sense of it. So of course it's about multi-channel analytics, because you have to analyze its data from social network, which is user-generated content. You have to analyze that data from a web source, which is the data from search engines and forums, e-commerce sites. And you also get a lot of device-generated content, right, from Internet of Things, such as also robot vacuum cleaners, smart fridges, bands, etc., etc. We also have some offline data, domain data in an industry, proprietary data. Offline data could be, let's say, transactions in supermarkets. So how to leverage all this data together to make sense of it holistically. So it's not that your offline data will contradict and restrict your online data, but rather they'll help each other. And you as a business owner, as a builder of this observatory or builder of some new platform for digital marketing, let's say, or for facility arrangement, can actually help you to do a better job. This is one of the key challenges, covered by many. So, okay, there's just a couple of articles that we're talking about, and I think the most important here when it comes to building these kind of systems and even research is this not that we have to process this data holistically as just one incremental step, but it's rather that we get a new research paradigm here, right? So last time we were talking about some experimental, theoretical and computational science as a new paradigm, but nowadays we are getting this data-driven science, when we don't just do like assumptions, or don't just do a lot of experiments, or don't just do a lot of computations to figure out, but we actually get data. Then we try to figure out what is inside this data. So the data scientist, very popular job nowadays, right? Like trying to make sense of the data. And this is a new research paradigm. It's a new shift in the research. That's why last time, like if you get somebody in a 50s, 60s, a researcher, a professor, they'll tell you, oh, you know, you have to put a lot of assumptions, you have to build a model, make a theory and all this. And if you could talk to some very young research fellow, they'll tell you, hey, you know, get a data, try to figure out what is there. And then based on that, you could try to start tidying in the particular theories that have been before to build your research around that. So this is also how we follow in our lab, because we believe this is a new age of research. We also have this so-called social machines. So social machines is pretty much that machines really empowering human a lot. They're not replacing humans, they empowering human in what we are doing, and they're assisting us a lot. They're also able to process this huge amount of data to help us to make decisions. So this is another application of this data. And it actually able to create some new types of social process and to impact the world, right? So you can read about social machines in one of these articles. You can see the reference in the bottom. We have social observatories, and we have application of social media analytics to detect the rumors. So if you look at this, how many? 7, right? 4, 5, 6, 7. Yeah, seven news articles. Actually, 2 of them are rumors. These 2, and the rest are true. And these rumors sometimes get very, very powerful. So some machine learning approaches, some algorithms that are able to detect rumors from real information by validating this from multiple sources is not just very interesting research problem, but for example, very, very interesting and also challenging problems that Facebook is trying to solve nowadays, because there's so many deep fake images and avatars and content get generated. So many rumors get spread. Facebook shouldn't allow this to grow big, because it might confuse and mislead many people. So they spend a lot of efforts in the Facebook AI research lab to detect these rumors, and this is one of the obvious applications. There are different aggregation platforms like this one, where people are posting content. It's more than it's called Zoo Universe. It's more than 165,000 people putting in content and thoughts about that. This all get aggregated. This all get put into a particular bunch, like in Pinterest, and you can see the structured information about the animals, about social events, about the space, etc. You can also have even music-related data banks, where musicians are composing, looking for creating particular music, listen to particular music, and others actually looking into what these people are listening, trying to make inference, try to sort the popularity. And then if you go into the industry level research related to this, it will be, let's say, about what is Spotify is doing as their AI research, and many other like iTunes, etc. Like those services, they do a lot of research on this recognition of the textual data. Okay, so actually I get one question here. So yeah, by the way, you can ask questions in the chats and I'm happy to respond that. So the question is, why does one need to analyze data that is pages generated by scripts? You need to analyze this data because these scripts generate data based on some basis, right? Basically, right? So if you have like somebody need to write a script, and this script is meant to do some updates, for example, on the news. In social network, scripts will be generating those messages that you post. So if you are not able to index and analyze this data, then you'll be end up only working with 4% of very structured data and not handling the whole internet, right? So this is a reason why is data generated by scripts actually the data that we need to analyze. We need to, because this is directly related to human wrote in the internet, or it can be related indirectly because somebody programs the scripts to do some updates, to modify websites dynamically, to upload some new information that we need to grasp in order to also stay updated on our site, all these observatories platforms. Okay, I hope I will answer your question. So we have Twitter. You can classify types of users and also types of events on Twitter. We'll be talking about this about this diffusion effects in one of the later lectures. But point is that users are also different. Their personalities are different, behaviors are different, and depending on this, for example, you can show different advertisement to them. And if you're able to do this correctly, or even if you're able to modify the advertisement based on what is, let's say, personality of the person, then of course this is a very, very powerful application. That's, for example, how social networks can make their advertisement much more relevant, and therefore they'll be getting much more revenues from the brands because they'll be interested to show this relevant advertisement to people. You have lab number 3. That's, I think, about predicting personality, right? So this is just about this, about the personalization and profiling. We have this NUS Live Web Observatory. This has been created by Lab on Media Research in National University of Singapore. Is my previous university before I start working in ITMO. And what we did there, we created observatories that monitor social media networks. At that time, they were the previous elections in India, and actually we were predicting who will be winning the election based on the Twitter and social media data. And that observatory get published in quite a bit of mediums. Nowadays, this observatory exists in the form of a company called 6 Estates. It's quite I would say late stage, I think Series D startup that do a lot of social media data analytics. They are famous in not just Singapore but also worldwide. But they are from Singapore and they come out from research. So this shows that if you have a very powerful research systems, you could actually build a sustainable business based on that. And as your final project for this model, you actually have a chance to build your own system. And you will team up with somebody else to build the system, and you can decide what it will be. We will be only helping you to assess the scientific impact of that, but we wouldn't be interfering much. So you could actually come up with some startup idea along this direction, and then maybe you can continue it after the course. So we're happy to help. I'll talk about this mini project in the end. So what are the challenges? And just to recap, the key characteristics are the data is very big, very live, very dynamic, very evolving. So social networks, they support the user's needs of communication, sharing, and interaction. It supports the co-viewing, co-creation of content, which was not available before, and we need to develop this kind of analytics algorithms that not just able to handle and make sense of this data, but also have to do it very fast and a very, very scalable manner so that we can really process all those billions of data points that Facebooks and Googles of our world generate nowadays. The requirements for unstructured data analysis, of course, therefore are how to represent this data, because data is very multimodal, very unstructured, and it comes from different sources. So there's no one fits all approach to make this data representation, to basically break it down into features that will make it sound, make it look good. You also need to be able to handle the noise, some information, and have to address the privacy concerns. You need to make your application useful, so you need to offer insights, you need to give a knowledge, you need to show the right content to people, you need to create actionable insights that help people to leverage this data to do a better job in whatever they're doing. And you need to have generate values to users and communities. So you probably don't want just apply advertisement in e-commerce to sell, but you also want to use this data to, let's say, help community, let's say, use social media data to predict natural disasters, to find for people who have some depression traits, right? To find some communities of criminals, etc., etc. All this can be done, and this is really helps impact the community, and this is useful applications you really want to think of when you are working with social media data. On the user level, of course, the key property here is the relationship between users. So the challenge is how to work with this graph structure, not just with the user content, because they're not in a space, they're connected to the rest, right? And you want to know how to work with this graph. And user graph is basically the two key components. The vertices are the members, users, and also the edges, a relationship between them. So that when you want to represent, mathematically speaking, it will be adjacency matrix and lists, right? So you want to do that. If you talk about it as like about the challenges, you can you want to predict some influential users, you want to find some communities of people, you want to infer users' interests and do user profiling, so going beyond interest, predict their so-called psychographics, predict their key personality traits, etc., etc., etc. On the content level, you need to know how to handle the content that is not just textual but also visual, but also the temporal content, because when we talk about videos, it's not just even visual content, it actually changes over time. So how to figure out what is important, what is not, what brings information, what doesn't. So much noise, data is so big, it continuously pumps in, so how to process this in the right speed. This is all the challenges modern social network platforms and big data systems are facing. And then we go to 3D, and 3D gets more dimension of the visual data. We also get AR and VR, which is pretty much understanding our real world, and that can bind back already to, let's say, self-driving perspectives, augmented reality. Then when like, let's say, in COVID, it's very important to educate people, to meet people, but actually physically not being nearby. So how to process this kind of data that get generated. And then it goes to online to offline, it goes to telco data, it goes to our phone, our location changes, etc., etc. How to process this type of data in order to really make sense of it and make it useful. So all these are important. Quality of the data is a concern. Why? Because, as you know, nowadays people post first and filter. So most of the data, I say it's 30% of the slide, but actually it's way more. Maybe 70% of the data in social media is really noise, or maybe it's not just that useful already. Even this data talks about user, but it's going to be very useful for analysis to figure out the intentions of the users, to understand his real personality traits and all this. So how to handle that? How to make sure that wherever you process actually makes sense, actually is helping you in your processing, how to handle misinformation, rumors, and other things, how to make the data structured, how to represent it, how to integrate this data so that your models that you build can actually leverage on the structural data representations of different data modalities to integrate. This all something very important. And of course, how to make it scalable, how to be able to really process the data at the levels that data get generated in the modern social networks. On the model level, you want to consider online and offline data integration. So you want to, like online data, it represents some segments of population. Offline data often represents other segments of users. And offline and online quite often intersect not that much, and it's not obvious who is online, who is offline, who are these people, how they're related one to another. So if you want to really integrate this data well, you need to make sure that that your data representation not just consistent and effective, but also mutually complementing. And you need to have a full picture of the world, which we don't. So this is a challenge. Privacy, very important. Nowadays, so many privacy scandals happening in all over the world related to social networking. No need to talk about it. I mean, you know this. You have heard, you read the news, you'll see a lot of aspects, and it's also huge research direction. Passive social networks last time, active social networks nowadays. People do a lot of interactions. Content between more rapid, more fast, bigger, more evolving. So how to do this, how to handle this evolution inside is very important. New AI paradigms, writes like how do you represent the knowledge, how you want to make sure that these AI systems are get more acting as a humans, that really perceiving this data in the way that humans would do and not biased, and also not overfitting the data in your training data sets. So it means evolve together with the data. This is one of the key problems as well Facebook is tackling nowadays, right? They say if you train a model today, after 1 week, this model no longer works because data has changed so much. How to make continuously learning AI data processing systems that are able to evolve together with the data because they always relevant. For example, for fake content detection, right? This is very important. So this is what the course about. It's technical. It's quite I wouldn't call it heavy, but you have to work. And the reward of this course will be that you'll get quite a good knowledge, and you can say that you are able to use social media and AI analytics for your work in the future, because you're going to get quite a bit of hands-on experience in this course. The main objectives, of course, is to basically let you understand the technical aspects behind the media computing, and we will let you know how to cover the techniques to analyze social networks, analyze the relationship between users and the graphs, and also how to analyze the content, visual content, textual content. This is not necessarily related to social networks, the general knowledge of NLP and computer vision that you will need anyhow. So in our course, it will not be more about theory, but it will be more about practical analysis of actual live data, so that you will be able to understand that, you know, not everything in the world is just like those nice handwritten digit minist data sets you can find in machine learning community. Actually, the real world is much harder, much harsher, and you need to be able to handle this. And this will be teaching in this course. We will be talking mostly about microblogs like Twitter, like maybe Foursquare, maybe Instagram. We wouldn't be talking much about closed systems like Facebook because we don't have access to their data, and we don't want to get this data if we cannot have access to it, right? So we'll be trying to get the data through the APIs for our data sets. And the outcomes is that, of course, you'll get some expertise and competence in designing, implementing, and deploying social media systems. And you'll be able to understand how actually architectures of this data processing system can work. And then you would probably really like social media analytics after the end of this course, because the assignments that we do are really exciting and you can really work with the real world data. I think this is the most interesting part of this. So we, at this moment, gonna have our lectures from somewhere around 12 to 1:30 Moscow time zone. I know some of you are not in Moscow, so not my Moscow time zone, so I'm telling you it's Moscow time zone. Let's say in Singapore it's +5 hours. So it will be around 12 to 1:30. We will also have tutorials and labs. Tutorials will be led by 2 research assistants that I name to you in the beginning. And I guess our first lab will be after lecture 3, and that will be about lecture 2. So you'll have less labs than lectures, less tutorials than lectures, but you have to do that. So you'll have 3 lab submissions. So far 3, sometimes we reduce to 2, sometimes we keep 3. It depends on our workload for this semester. It's individual every time for every new module. And you will have, most importantly, the 1 mini project that you have to complete with 2 or 3 of your peers inside the group. So you'll have to work together, come up with a concept, present this concept to us. If you like it, then you'll be developing over the course, and then you'll be presenting that, and that will be also contributing into your final score, final exam for the module. Sometimes we have exams, sometimes we have lab, the mini project combined with exam. So we always have something like exam in the end, but the exact format is always again comes out from the way we work during the course. So I will be assessing you based on participation. It's about 20%. Lab submission, each lab is about 10% of your mark, and your mini project. So just for Russian students, want to mention, even if you do mini project very well and pass exam very well, you only will get 50% of the mark, which in a 5-mark grading system will be 2.5, rounded up to 2 out of 5, right? So you have to do the labs, you have to participate in the lectures, otherwise you might not get as high mark as you deserve. And this is probably one of key differences of my course compared to other courses that we have. In our course, you really need to work whole semester in order to get good mark in the end. And we always, on your side, we're always happy to help. So reach us to research assistants or to me at open hours. I'll be happy to help you. This is a course schedule. You can go through it after the course, after the lecture. I'll upload the slides. This also could be modified slightly, so you might get new lectures in and cut some of the lectures, but roughly this is the topics we'll be covering, so you can set up yourself to cover these topics. And the weeks 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then it will be the exam week in the end. So rough schedule of the labs will be week 6, we will be submitting lab number 1, which will be about classifying macroblocks. Then on week 7, you're gonna add additional features to this lab, and it will be a sentiment analysis based on microblock streams. So basically, lab number 1 and lab number 2 are kind of combined together. And then lab number 3 will be about personality prediction, and submission due is week 10. In parallel, you'll be working on your mini project. So the mini project gonna have 2 consultations on week 8 and week 11, and then you'll be presenting it in week 13 and also during the exam in a group, and we'll be taking care of each participant's contribution into the project, right? So we quite often can get different marks for the mini project within the same group. So some other details, well, will be some references. You can get references inside the lectures. You can Google them, quite a bit of information in form of tutorials. In Google Scholar, you can find papers. If you can go a little bit deeper, it's all appreciated a lot. We have our Telegram channel. So I'll be announcing everything there. If one of you or some of you are not in the channel, please go into there. I'll be announcing things there, including the Zoom links, if they will be changing. Lecture notes will be posted after the lecture every time. And the consultation hours are bi-weekly on Fridays, 11 to 12. Let's keep it like this first, but then in case we need more, we can extend that time as well. So the final remarks about you, it's going to be a really fun module if you work on it, and you'll have to work because there's quite a bit of programming involved and quite a bit of learning for you. We don't care memorizing, we care the actual knowledge outcome. So whatever tests you'll have, it will be all related to the open book exams. You can use whatever resource you want. Let me answer some of the questions. So can we do our project in a group of 4? You could present it to me. Usually we suggest a group of 2. Yeah, I need to have a very strong reason why it will be group of 4. And for group of 4, the complexity of the project must be significantly higher as compared to those that will be done in group of 3. So we will be treating you differently if it will be 4 people inside the team. Telegram chat apart from the channel. Yeah, we can create Telegram chat. I'll ask assistants to create that so we can discuss some problems inside the chat as well. That's not a problem. Okay, so guys, remember the dates. Make sure that what you have seen is what you like, and see you next time when we'll be talking about text retrieval and classification. Have a very, very, very nice weekend ahead. Bye.